Bridget Krumhout, and we're going to talk about cloud-native platforms and a lot of related stuff. The obligatory second slide that you always wish didn't exist, but it does, so whatever, is that, because you always think like, why is this slide here? Because they don't need to sell me on making me listen to them. I'm already here, I'm in the room. But I kind of like informing you a little bit about my background because that tells you about the context that I'm approaching everything from. So I was on call for production infrastructure from 1999 to August of this year, which is long enough to get really sick of being patient in the middle of the night and to build up a lot of animosity over time towards those cowboy devs who like YOLO shit out into production, and then I'm just left, holding the pager. And I think one thing that's been really great for me about embracing DevOps is realizing that instead of saying it's an us versus them thing and the devs just make everything terrible and I have to suffer through it, it's how do we work together to make things less terrible. I also have spent a lot of time fending off the Bay Area recruiters. The line that I find works the best is when you explain to them that snow is a feature, not a bug. When they try to recruit you in like February, they're like, you should just come out to California for an interview, and you're like, let me explain. I co-host a podcast called Arrested DevOps with my co-hosts Matt Stratton and Trevor Hess. And that's actually a lot of fun. I'm not on every episode, and I am not positive I've actually listened to every episode, but a lot of the episodes are about stuff in this infrastructure automation space that are pretty interesting, I think. I might be a little biased, so you should listen to them and check it out. I'm part of the shadowy global cabal that brings you DevOps Days. Did anyone here make it to DevOps Days Minneapolis the last couple of years? Nope, one person in this room, excellent. A couple of people last time as well. We're gonna have our DevOps Days Minneapolis is gonna be July 20th and 21st this summer. We'll be at the Hilton downtown again. And we have a discount code when our registration goes live this weekend. I'll put a code free 16 discount code in there for some amount of discount to be determined, just because you're here. And let's see, and the only other thing is I work at Pivotal. So Pivotal is you may have heard of Pivotal Tracker or like Pivotal Big Data Services. I actually do technical advocacy for the open source Cloud Foundry platform. So the nice thing about being in advocacy instead of sales and focusing on open source is that I'm not incented by commission, and I don't care if you write us a check. But I would very much like your lives to be better. So we'll talk a little bit about the kind of patterns you're going to want to look for when constructing your platform. Whether or not you end up using any of Cloud Foundry's code to do it, hopefully that gives you some building blocks that'll make your platform, more operable, more secure, and better, more reproducible. Because it's easy to say, hey, I deployed something to production and it's running and it's great. Well, sure, that's fantastic. Now do it again, n times, repeatably. Now roll back. Now roll forward. That's a lot harder than getting something out there once. So having the tools to do that right is what we're going to talk about. I think that this is a space where it starts to get really difficult to navigate those choices. And yes, that there is maybe a little bit of an Easter egg with the Kubernetes logo in there. And basically, if you're looking, I'm not going to spoiler alert, this talk is not going to give you a giant matrix of exactly where you should use Kubernetes and Mesos and Marathon and Docker, and because if somebody tries to give you a pat answer like that, they're lying to you. They probably want to sell you something. So if someone tells you, I have the solution to all your problems, because they don't understand your context and your problem space the way you do, they're probably not serving you well by telling you they can solve your problems without understanding your problems. And that's why I think that it's really useful to look at how other people are solving problems and then decide for yourself how to solve them, as opposed to when somebody in the C-suite plays golf with someone and then buys something and you're like, well, now I have to make this work, fantastic. It's hopefully that's not how we're making our technology decisions any more than running a Markov bot against the front page of Hacker News and implementing that in production. Says the person who has run Docker in production. But speaking of that, I'm going to start with a story to give you a little bit of context of where I'm coming from. My last gig, I spent a year in the ops team of a streaming video startup called Drama Fever. That was very much like Netflix. If Netflix were much smaller and mostly Korean soap opera and ran Docker in production. Okay, so maybe not entirely like Netflix. They have a lot more in the way of JVM stock traces than we do. And they open source a lot more. But The Docker in production thing gets people's attention, but there's a lot of reality beyond that hype. Because that sounds really shiny and exciting, and you're just thinking like, dev takes a Docker file and does a Docker build and like, pushes it somewhere and does a Docker run, and everything is hunky-dory. But the reality is, oh yeah, okay, if you're gonna be running Docker in production, you're gonna want your build system controlling the provenance of your images, right? Because you can have things in that Docker file, like an add from whatever is in your current working directory. Who knows what that was? Are you gonna be able to reproduce that? Or if you're doing package installations with no versions, well, okay, so that moment in time that you did the Docker build is when you're going to get those results. Later, who knows? Who knows what you're gonna get? So there's a lot of demystification. I gave a lot of talks last year about like our journey at Drama Fever with Docker and just demystifying this. It all seems easy until you actually do it, right? But since almost everyone in the room is a developer, you know how the sausage is made. Like, you know that this stuff is not actually easy. Complex systems are complex. News it a lot. The specific environment we were operating in is we had a monolithic Python Django app, and started trying to, in 2013, started decomposing it to Go microservices, because that was a very trendy thing to do at the time. And the problem that we ran into immediately was with our deployment process. The reason for that is you would think, oh, well, there's probably downtimes. I mean, look at your load. Like, because most of our viewership, most of our licenses for the Asian content that we would get were for use in North, Central, and South America. So most of our viewership would be at a very specific time of day. We had the very Netflixian, sine wave of traffic. So, all right, I mean, even if your deployments are kind of a problem, not a problem. You can do, you can do your deployments at a low traffic time. Well, yes and no, right? Because the low traffic times here were about the high watermark of API requests at my last startup. So, because as it turns out, people watch fewer K-dramas when they're sleeping, but not no K-dramas for inexplicable reasons. Like, they are still actually watching stuff. So, because of the kind of usage pattern that we had, we wanted to be able to have zero downtime deployments. And we're in 100% in AWS, doing all the auto-scaling AWS magic that you expect. So this is pretty simple, right? Well, we started out with just checking out the Python code onto an Amazon instance, baking an AMI, and going. And then it could scale up new AMIs with the current code base. This was fine when it was fine. For some values of fine, because of course it was kind of slow, and sometimes the get checkout didn't go exactly as expected. But it was mostly fine when we were doing just Python. When we moved to Go, we suddenly had a binary we needed to ship. It's like, this isn't going to work anymore. We took a look around. Again, this is 2013. It's like right before I joined, and we realized that bringing Jenkins into the mix and having, instead of Jenkins just running our tests, instead of just tests, having Jenkins do builds of a Docker image, and then either put the Python code on the Docker image or put the Go binary in the Docker image, would allow us to ship a version deployable artifact in both cases and use the same deployment process for both of our Python and Go services. So that was pretty great. That worked pretty well. One thing that I think, when a lot of people start using Docker in their organizations, because it is, developer catnip, it ends up starting in the dev and test environments. We actually started with Docker in production before every developer was using it on their laptop, which sounds backwards, and maybe it was, but the reason that we started finding value in having the developers use the exact same Docker images on their laptops that were being built out of our Jenkins system is that it works on my machine is, a stereotypical comment, but what about I blew up my build environment, or a new developer started and now they have to go through like the 50 steps to get their build environment going. If they get their local development environment configured the way they want it to. So if a developer can just install, we were using Boot to Docker at the time, now Docker Toolbox does this, but if a developer can just install Docker Toolbox and do a Docker pull of an image with a given tag and be up and running with a local copy of the site that they can start developing on immediately, that's pretty powerful. It also is really useful from an operational standpoint because of being able to say, this is the image that the containers in production are running from. Let's take this exact image and try to reproduce the failure that we think we saw, or troubleshoot with it. So while having Docker like in your test environments is nice and useful. If when you get to your production step, it's not the same, then you can't actually do the same kind of tests on what's running in production as you would want to be able to. So like that's one thing right there. So like that was really useful. Another thing is, when I tell people when we started at Drama Fever using Docker in production, the reactions range from like, it's probably fine, to like, well, that's terrifying, because we started using it in October 2013, when I think the main thing on the Docker website was like giant text, maybe with blank, that said, under no circumstances should you use this in production. And we were like, okay, this sounds great. Because, I mean, realistically, it was based on the underlying technology at the time was LXC. We're like, okay, we can fall back on the more mature LXC if this doesn't work out. Spoiler alert, it actually worked out pretty well. But I think this is one of those things where if we had had some kind of, because we're a startup, it was a lot easier. If we had had a change control review board telling us that under no circumstances would we be able to use this in production until they had seen some, some reference customers of Docker Inc. That, and it's like, customers. If by customers you mean it starts on GitHub, then yes, absolutely. But if they didn't have like someone to point to who was like them, who was successfully doing it, a lot of organizations shy away from doing something like this. So that is one advantage to being in like the small, fast-moving orgs, is you can kind of do stuff that people think is a little bit yellow. And I was in an ops team, and a lot of developers, I think, with reason, with good reason, think of ops people as sort of curmudgeonly and not very much like them, like not really in your tribe. But like, I got news for you, right? Like in the infrastructure as code space, if you're doing it right, TM, you're doing peer review, you're doing pull requests. You certainly don't want an irreproducible 30 clicks on who knows what is what got your production infrastructure into the state it's in now, and let's hopefully not touch it. And maybe when Barb or Bob gets back from vacation, we can actually upgrade that. Like, that's a terrible situation to be in with your code, whether it's infrastructure code or customer-facing feature code. So this is kind of where, like, no one wants to write documentation, right? It's like, I mean, raise your hand if you love writing documentation. Okay, I see one hand. So the one sainted person in the room who likes to write documentation can ignore this statement, but I'm gonna put myself out there and say, most people do not want to write documentation because it feels like it's going to be outdated pretty soon, and it feels like no one's going to read it, and it feels like there's no point to it because people should just look at what the code actually does. And I think those things are all true, but also what the code actually does is not going to tell you why someone did it that way. So I'm a huge fan of really detailed commit messages, so that you can get the context of that point in time when that bastard, probably you 6 months ago, did this thing that is now causing everything to be a slow-burning tire fire, and you want to know why. Like, having that rationale of why is so much more useful than like, this is the function that increments things, and you're like, no shit, Sherlock, I can see that, but why the hell are you incrementing this? This makes no sense. So this is definitely true in infrastructure too, especially when you have super wonky things like maybe you're in AWS and you had classic EC2, and then you set up some VPCs, and then you're using the classic EC2 connect, back to the classic things that you can't quite move to your VPC yet. And then there's a few IP addresses that because you can't whitelist the security groups between AWS accounts for the VPC. And so then there's some IP addresses that you put into your security group rules, and you don't really know why. And then somebody, I don't know, rolls some instances because of there's like the great Zen rebooting of today's newest CVE or whatever, and suddenly everything is sadness and you have no idea why. Because somebody just went and clicked on some stuff, didn't check anything to source control, and you don't know why this happened. It's like, this is a huge problem in infrastructure. I would say it's a sort of problem in infrastructure that can be even more devastating than in your feature code, because the likelihood that anyone's going to be able to tell what you did or why is pretty low, right? So this kind of brings me to the there is this, automate all the things meme, and I sort of think it's wrong. Like, you shouldn't automate all the things exactly as you currently do them without examining what you're currently doing, because it's possible that what you're currently doing is a terrible plan. And it's either not really reproducible in the kind of automation you want to do. I know I've definitely written some really laborious chef recipes with so many places to break out of that logic, because I don't really want this to run every time, and it's like, as soon as I realize I don't want this to run every time, I'm like, why am I putting this in Chef? This was a terrible plan. But you know what I'm saying? It's like when you have, what you have is the PHP hammer, then everything starts to look like you should hit it with that. So even though it's possible to build a total Rube Goldberg of a deployment pipeline with a whole bunch of fragility and asterisk, if only, and I hope we don't, and as long as built into it. Like, I've totally built these, you probably have too, but this is me saying, let's be a little bit more, it's 2016, like we probably don't need to build super ad hoc, artisanal, bespoke, hand-whittled, build, ship, run sort of platforms. Like, and I say this as somebody who totally has, but we probably should. Like, we can, but like, should we? This is an image from Simon Wardley. Interesting thinker on Twitter, talks a lot about conceptual maps, understanding your territory. I sort of disagree with where he draws the line of like where your platform boundaries actually are. But the point is that there's a lot of hype right now around containers and the orchestrating thereof. And from my point of view, and I have spent a bunch of time in this space, the containers are very useful and very important as a boundary object to allow you to ship things that have a context and need that context. Like, that's valuable and important, but just rubbing some Docker on it does not magically give you a platform. And a lot of people who, especially when ideas are coming, if you're using the Hippo model, like the highest paid person's opinion, they will often tell you that you absolutely need to add some microservices and probably some Docker. And I think that you also need to buy at least 18 units of DevOps this quarter. And like, when you're having people make demands like that, you start to not want to even do any of that stuff because it sounds ridiculous, and maybe the way you've always been doing it is actually fine. And like, all of the things that they're demanding are actually probably a good idea, but grabbing each one of those components is not. Like, thinking about it from a more holistic point of view first, before you start grabbing and trying components, makes a lot more sense. So if we're going to talk about platforms, and like not usually orbiting space platforms with lasers, though that would be pretty awesome, but if we're going to talk about platforms, I think it's useful to kind of define like what we think is in a platform and what we think cloud native, whatever that means, actually means when it comes to a platform, right? And I would state, like, if you already have a platform, if you're thinking like a platform, that should be on the wish list, that should be on the checklist, that should be something that we should add at some point. Like, you already have a platform if you have software, right? If you can deploy your software and it can get from, your ideas to production in front of your end users, then you have some sort of way to get it out there and you have some sort of way to run it. Now, how happy you are about the way you have to get it out there and the way you have to run it is an entirely different question. And if you're sitting in this room, it's possible that that's something that you're working on and trying to improve. But I mean, you do have, like, table stakes, you already have a platform. It might be like the most recent platform that I built out of, Docker and Packer and Chef and a bunch of Python. It was Fabric, which is like one step above SSH in a for loop. And, but lets you talk to Bodo, so you can talk to AWS, whatever. And a bunch of janky bash, because like, if someone has a hand-whittled artisanal platform and they tell you that there's no janky bash underlying at all, like, they're lying. There's totally bash in there. But the question is, how many opinions does your platform have that came from you versus the wider industry? And I think this is where, as engineers, as builders, as people who want to make things, it doesn't sound fun to get anything with structure or opinions in it whatsoever, because you can build something really cool. And you're right, I mean, you can, and you will build something really cool. And then that might be the main thing you spend a lot of your time on, instead of whatever it is that your workplace hired you to hopefully accomplish for them. So this is kind of the warning of like, this is when I worked for Andrew Clay Schaefer at Pivotal, and when he tweeted this, he later admitted on a podcast with Kelsey Hightower that he was mostly just trying to troll Kelsey, who's like Mr. Kubernetes. But when Andrew tweeted about structured and unstructured, opinionated and unopinionated platforms, I really do like this analogy, even if it's supposed to be a joke. Like, I actually think it's a good analogy, because if what you want is a treehouse, like, you should definitely get a treehouse. If your kids want a treehouse and you show up with some 2x4s, they're going to have a bit of a wait. They're not going to be very happy. Or if you want to play on the treehouse, you might not be very happy. If what you want is to build a treehouse and you have a wide variety of saws in your garage, then, and the ground isn't frozen, then go for it. But going into it without thinking about that first can lead you down the path of cobbling together a lot of pieces without actually having a plan for how you want it to end up, which is not necessarily the best plan. So then if you're thinking, oh, wait a minute, there was supposed to be way more buzzword bingo in this talk. There is, but if you think about it, in many ways, all of these things are aspects of the same phenomenon. So if we're looking at continuous delivery, that's going to get you to what you want, presumably, which is operating reliably, effectively, at scale, fast. But if you're going to think about how you're going to get there, you probably have to have inter-team cooperation to make that happen. So you better get some DevOps there. If you're going to think about what kind of architecture is going to make it possible for you to deploy different pieces of your infrastructure, of your application independently, then you need to be thinking about microservices. But you don't usually go into it thinking, I definitely need some DevOps, even if external forces are telling you that that's what you need. You have an actual why, and looking at your actual reasoning is going to help you arrive at which pieces of those to implement first and how to implement them a lot better than just saying, here's a giant checklist of very important things, we need to do them. A little bit of a digression about containers. How many people here have played with containers in any way themselves? Yeah, about maybe a quarter of the room. And how many people here have actually used containers in production in some way? Yeah, exactly. It's like every time I ask that question, you might get a handful of people in the room. There was Donnie Burkholz is an industry analyst who lives here in Minnesota, actually. He's going to be giving a really good DevOps 101 talk at the DevOps Minneapolis meetup on Monday night, by the way. So if you look at devopsmsp.org or just look at DevOps Minneapolis meetup on meetup.com, it'll be held starts at 6 o'clock Monday night at Target Plaza Commons, downtown Minneapolis. But Donnie I posted something on Twitter earlier today that I need to ask him about, because it said that as of end of 2015, more than 20% of organizations report using containers in production. And I'm like, okay, I would very much like to see the underlying data under that, because a lot of people I talk to are not, and they're interested in it, they're just not using it. And what I think we need to remember is that containers are not new. They've actually been around in the form of, whether it be just C groups, namespaces, C groups and namespaces were mostly prevalent around 2008 with the development of LXC. But if we look at Chroot or FreeBSD jails or Solaris zones, this stuff isn't new. But the recent adoption of and practice of the stuff that Docker has brought about is. And I think that when I was originally saying, well, Docker, this is a giant trendy meme, but this stuff isn't new. I was wrong there, because I wasn't realizing that having decent APIs that make containers more accessible to developers was a huge fundamental sea change. The containers that we were using, you needed to be an ops person who had cut your teeth on a reasonable amount of Unix to make them practical. And now it's much more accessible to an increasingly wide variety of people to actually use containers. So I gotta give Docker a lot of props for that. I also gotta give them a lot of props for the Open Container Initiative and for open sourcing Runc, because I work at Pivotal, and Pivotal, like CoreOS, like a lot of other people, had their own container format they were using. We're moving to the OCI specification, just like, it was really funny. As soon as Solomon Hykes put up a slide at DockerCon last summer of a dove with an olive branch, I knew what was coming. I knew it. And sure enough, he pulled Alex Polvey up and shook his hand and said, you know what, we're burying the hatchet. We're not going to be at war with you over Rocket. We're open sourcing OCI, and just join us. And I think that direction, that the open standards, working with foundations, that sort of thing, that a lot of stuff is going, I think is really powerful. Because, again, back to the undifferentiated heavy lifting, if Docker has done a pretty good job of defining a container format, then if we're gonna sit there and say, but Rocket, but Wharton, whatever, it's kind of like, arguing about what your favorite flags for tar are. I mean, I don't know about you, but mine are XVF. It's like, this is not, should we talk about the controlling PID? It's like, these are not interesting discussions. The interesting discussions are what we can accomplish with these tools. I also think that there's a lot, this is a Gartner hype cycle, and I think there's a lot of hype around containers that people then start to get really disappointed when they realize that they're not magic, and when they try to rub them on their architecture, it doesn't suddenly turn into a beautiful butterfly. It's like, unless it's Perl 6, doesn't Perl 6 have a butterfly? I was very confused by that. It's like, what's going on there? But anyway, so I think that the place that we're hopefully all going to be getting with our, our use of cloud, our use of stuff like containers, is this like productivity. While the stuff isn't magic, it's also not as terrible as I might have said at some low points last year when I was really upset about Device Mapper. It's like, Docker storage drivers are all terrible because overlay file systems are sadness, but that's focusing on that, again, not a good way to move forward. I like looking, if we want to see actual progress, I like looking at the example of what 18F is doing. So when Mikey Dickerson and his band of Google SREs went and saved healthcare.gov, a bunch of them stayed, and aside from just the US Digital Service, they also are building out this innovation arm of the US government called 18F. And they do a lot of enabling of other agencies. One of the projects that they were working on was like an app for veterans to like check their benefits. And the reason that they went with, and they actually went with open source Cloud Foundry, they didn't write Pivotal to check, they just went to GitHub, and that's perfectly great. Like, again, it's like, I'm focused on the open source stuff, that makes me happy. But they went and set up cloud.gov specifically because they didn't want the people who were focused on building that app for veterans to also have to worry about the deployment pipeline and logging and monitoring and all of these things. And it's like, and how to scale it, if there's a big spike. And so that is, I think, kind of powerful to, when you look at, what you would consider to be large organizations that aren't necessarily super innovative and don't necessarily move super fast, still realizing that if they want to enable some subsets of their organizations to move more quickly, they have to give them the tools to do that. Mark Imbriaco, who is a really fascinating guy, he ran ops at GitHub, Heroku, DigitalOcean. He's doing a startup right now about tools for ops engineers. And he tweeted this like back in 2014, kind of this idea of like, people kind of think DevOps is synonymous with tools, and it really isn't, but you do need tools. Like, tools are an enabling force that are going to make it possible for you to have the culture that you're trying to build inside your organization. But if people think that by doing DevOps, what they should do is like build half of Heroku, that's not actually going to get them some DevOps. It will probably get them something that might be kind of hard to maintain, and then when some mindshare walks out the door, be super hard to continue developing. So that's why, again, like how when you want to make a website, and so first you roll your own Linux distro, and then you develop your own web server. Yeah, no. I mean, maybe once, but like this is not what people actually do at this point. And so like building your own completely bespoke platform, something I've totally done, but it's something that you should at least look at the open source alternatives out there before trying to do. And like, I think a lot of times when people think of a platform concept, they think of a PaaS, and they think of something like Heroku, which feels very out of their control. Or they think, I'm putting absolutely everything into Amazon secret sauce, and now I have total lock-in, or whatever. And I think that it's more nuanced than that. Like, it doesn't have to be that. I mean, obviously, yeah, Amazon is moving up the stack. They're definitely not just a IaaS. They are definitely providing a lot of platform-like solutions. I mean, just look at Lambda. But at the same time, you can have a platform that you run in-house, whether in-house is just in your AWS account on EC2 instances, or on your OpenStack or vSphere or whatever it is that you have not quite amortized enough to convince people to let you turn it off. If you're running the platform, if you inside your organization are operating it, you may be operating it as a service for people inside your organization, but that doesn't mean you don't have control of it. You can still have control of it. I also think that's important, since we do tend to, in this space, we tend to talk about tools a lot, but I want to take a step back from the specific tools we're talking about and just kind of have a reminder that the general principles, getting those primitives right, are a lot more important than exactly how we implement them, and it's certainly more important than the tools. So just why we're doing this stuff is way more important than what. And I'll give you an example. So Etsy is really famous for being all DevOpsy and also for monitoring and graphing everything. And a lot of Etsy's operations team wears a Jawbone up, and they send the data from it into Graphite, and they graph it against their other alerts to find out how bad the on-call was and how hard it was for people to get back to sleep. I had a friend who worked at a place who really wanted to be successful like Etsy, and so they got Jawbone ups for all their engineers. Later, that friend talked to some people from Etsy who told him, oh, the reason we do that is because I was in an airport, I saw a Jawbone up, I really wanted to buy one, I talked to my boss, and he said, if you want to expense that, you're going to have to find some way to work it into your ops projects. And that's the reason that they do that. It's they don't do that because tracking your sleep data makes you better at opsing. I mean, it certainly might increase their empathy for their fellow ops people, but if you just cargo cult the practices of a successful organization without understanding why they're doing them, you might end up just with the trappings of success, but without any of the actual underlying motivations or reasons that would be a lot more relevant to your use case or your needs. If we're talking about a platform, again, if we're talking about the kind of constraints a platform brings, I think this is one place where, as practitioners, as people who build things, we kind of bristle at the thought. We don't like the idea of something that makes it impossible for us to get our work done, especially if that something is coming from the ops team, because I'll admit it, I've totally been that department of no, right? I mean, I've been the person who says open a trouble ticket and then does not do the thing in the trouble ticket. And that is different than the kind of constraints a platform brings, right? Because the platform is intended to enable the developers to move at the speed they need to move at, but the constraints are intended to make sure that everything that they do will actually work. So, for example, if we're talking about microservices, there is a lot of joking around how complex microservices are, right? But the reality is that yes, of course, microservices do add complexity. They're not going to make your system simpler. That's not what they're going to do. They will make it more comprehensible. And then people ask me how micro is a microservice? What's the right number of lines of code? And I think, no, it's not that. You got to think about scope, right? So the reason that monoliths can be a problem is that you're going to have things in your monolith, your giant software package that you've been developing for years. You're going to have things in there that nobody who still works there even understands or wrote or knows why it's there. You still have complexity. The complexity is just hidden from you. And you aren't going to see what's wrong with it until you trip on it. So the right scope for your microservices is to have a small, comprehensible chunk that does one thing, does it well, and talks to all the other services via APIs. And that's actually really important. We'll talk more about that. Specifically, if you read the Borg paper, and by the way, I think it's really interesting, it took Google about 2015 to put this paper out. I mean, they're usually pretty good about writing papers, and the Borg stuff was sort of secretive, but if you're not familiar with Borg, it's Google's secret sauce, infrastructure automation layer. And they spent a lot of time kind of teasing the public with it, not really telling them about it. A lot of ex-Googlers left and then tried to reproduce the Borg experience with something that they wrote themselves. Actually, if you look at Bosch, which is an infrastructure automation tool that underlies Cloud Foundry, Bosch.io, Bosch, B-O-R-G, it was written by ex-Googlers. They love doing that, it's hilarious. But anyway, so if you're trying to decide where the right boundaries of your microservice are, you have to be thinking about how do we want these pieces to talk to each other, and what do we need to deploy separately? Because your giant big bang deploys that are weeks and weeks or longer of changes, you have a problem with that. You have almost no choice other than to completely try to roll back, because you aren't necessarily going to be able to distinguish which one of the zillions and zillions of changes led to that problem. That's where continuous delivery gives you so much power, because if your delta of changes is that much smaller, then troubleshooting those changes is also way easier, and you may be able to just roll forward instead of roll back. Oh, wait, I moved away from this one without even talking about the most important thing here. So, the most important thing in the Borg paper, I think, is this concept of the application reporting its own status. And yes, sorry, I lost my train of thought, but that relates to microservices because you want your microservices to be able to have an endpoint that gives an answer to the "am I healthy" question. If that answer is going to be a nuanced "it depends," and also this part works but this part currently doesn't, your microservice is too big. Like those two things, the one that currently works and the one that currently doesn't, should be separate services talking to each other through APIs. Because if you can't report your health accurately, then you can't have your, this is again back to the reasonable constraints, you can't have your automation tooling take those, use circuit breakers or take those broken pieces out of the mix if the report as to the health is not accurate. Like if your health checks are full of deceit and lies, then Amazon's going to throw everything out of the load balancer and everything will be sadness and I'll get paged and I will hate you. I mean, or hopefully you'll get paged and you'll hate yourself and then try to fix it. So basically, if you read any of the stuff that like Mark Burgess or Jeff Sussman, who lives here in Minnesota, has written about promise theory, you think theory, okay, we don't need theoretical stuff, we need practical stuff, but it's good to have theoretical underpinnings. And the idea of promises is that if we want our platform to behave in the way we expect, if we want it to, isolate something that's not working or scale something up when it needs more resources, then we need to have our applications actually give accurate information so that the automation can make the right decisions, right? If the platform is going to make promises, and hopefully you want your platform to make promises, if it's going to make promises, it's a question of which promises it can actually keep, right? So if the answer is, it will definitely be possible to get more VMs when we need to scale. All we have to do is open a ticket and it's like you should just stop there, right? Because first of all, do you want VMs? No, you want capacity. You don't care about VMs. If you can have just like a pool of infrastructure that a whole bunch more containers can spin up in, that will be a lot faster. I will assure you that starting a container is orders of magnitude faster than starting a VM. Especially if you're starting that VM on an infrastructure as a service where you have to call it to their API or have your auto scaling processes of whatever sort call it to their API. It's like, and when you're thinking about speed and you're thinking, okay, sure, it might be really important to be able to spin stuff up quickly, automatically in production. But in our test or development environments, we don't move that fast. And it's like, well, but you do need it to be self-service, right? So if you have a platform that works really well for production, but your developers don't have one, or vice versa, you have problems. Your developers need to actually be able to simulate production. And if they might not have production traffic or the exact patterns of the workload, but they need to actually be able to simulate what the running conditions will be like. And if it ends up being much harder than you would think to get, say, a new database, if you have to open a ticket to get a new database for your development environment, it will seem very tempting to just start using that database that already exists, because what could go wrong? But then you have microservices that are talking to the same backing data store, and everything is sadness, and someone throws Sam Newman's book at microservices at you. It's like, you don't want that. When we're thinking about like, okay, if we're gonna have a platform, we're gonna have a decent platform for our development environments, for our pre-production, for our production environments, okay, what's the shopping list? What should that platform have in it? Like, I very deliberately don't have specific technologies on here. But the stuff that your platform should be able to do, and honestly, I think at this point, these are table stakes. Like, this is the minimum of what your platform should be able to do, is you should be able to route and balance traffic dynamically without needing things like fixed IP addresses. Or you should be able to have some sort of, whether it be using DNS or some sort of service discovery with like Consul or etcd or whatever, but you should have some way to be able to route your traffic without needing to know about your infrastructure in advance. And for people who have spent a lot of time in very traditional IT environments or operational environments, this is like, what? This is not a thing. But if you're trying to be cloud native, and by the way, I think the cloud native term is kind of wacky, because then you think, okay, none of us started out in the cloud. None of us, really. So do we need like a cloud integration and naturalization services to get us there? And it's like, I mean, you can be that in your organization if you can help people think about building things to be operable in an environment where their infrastructure might be ephemeral and they will not know the IP addresses or the port numbers or whatever of anything, but they need to be able to discover it. Your platform should enable you to do that. The backend services broker is this idea of, do you really want somebody using that same session store, because they already had a Redis, and so they just used that Redis for something else in their test environment, and it's okay because they'll be separate in production, except that when they were testing, this other app was also testing, and so they got totally polluted results because there was this false economy. Like, it used to be that things like disk was expensive, and so we had to try to conserve. It's like, okay, disk and compute and memory and all this stuff is relatively cheap now. Your time is expensive. And so having your attention is expensive. You having to try to work around constraints that don't actually need to exist anymore is one pattern, an anti-pattern in organizations that have not fully embraced cloud, whether that cloud be public or private, whether it be on-prem hybrid, however they're using cloud. The idea of using cloud is to have ephemeral on-demand API-driven infrastructure that you can provision and use at need and at will. And if people are still trying to impose upon you patterns for developing and deploying your applications that don't fit that model, like you can point to this list and be like, what we're doing now is not actually what we should be doing if we want to be more effective, right? So having a backing services broker that allows you to just say, I need a Redis and I need a MySQL and provision. If you don't have the ability to get push button, instantiation of the pieces that you need in order to be able to effectively develop something in an environment that models production, like, all right, your platform is not as good as it could be, work on that. The idea of infrastructure orchestration, I think, is really powerful because, again, the human as a keyboard, keyboard as a service, ticket driven. Oh, we totally have an API. The API opens a ticket. I have heard that from more than one, like Fortune 500 company, and it just makes me sad. So it's like, no, you don't have an API. You have OpenStack and sadness. But if you don't have the ability to spin up more infrastructure, virtual infrastructure, without talking to anyone or leaving your desk or opening any tickets, then your platform is not as flexible as it could be in order to allow you to move more effectively. We talked about health checks and health checks that are, sadness as a service, health checks that are full of deceit and lies. Like, you want decent monitoring and you also want auto remediation. Like, anyone who's ever been on call knows that getting that page that some disk is going to fill up next week is not something you wanted at 3 in the morning. And so if your infrastructure automation has the sort of threshold-based checks as opposed to responsive checks that measure how your application is performing, that is not going to serve you well in even the medium term, I would say. Because again, even if absolutely every Nginx process is not running for reasons that are unclear, but you still have work flowing through the system, hey, maybe somebody just replaced your infrastructure with some small Lambda and you didn't notice, right? It's like, monitor whether or not you're getting work done. Don't monitor whether or not you have certain processes. The idea of a reusable runtime environment repository, and I don't know if I would have phrased it exactly that way, but I like this list, and it came from my coworker Casey West wrote an article about cloud native future. And the idea of that repository is something like your Docker registry or something like Artifactory, where you can put your version deployable artifacts, not only of your software, but hopefully also of your infrastructure. Because that panicky moment of rollback where you're trying to reconstruct how things were when they worked is like, that's for the birds, right? You want a way to be able to actually say, it was at this version of everything. Again, if you have people doing infrastructure as code. And then log aggregation. Again, like, as a developer, it's really important for you to be able to actually see how your code is performing under load in production conditions without having to go bug somebody to give you access to some logs from some individual instance that may not even still be around if it spun in and out of existence. The logs being centrally aggregated is super important. What tool you use to examine and slice and dice them, less important. If your company has made of money, it might be Splunk. If you're, if you have a plethora of hipsters, it might be like an Elk Stack or something. Like, it's not necessarily important which, but you have to have some kind of centralized logging. Like, this is basically like bare minimum platform. If you're looking at the list and you're thinking, I have N of those where N is fewer than 6, like, okay, that's your homework. Go back to your place of gainful employment and try to figure out how you can improve iteratively. You don't have to have them all at once, but try to improve towards having these things. And having structure around those contracts on your platform that says, if this, then that, like having a lot of, if this and that built into your platform determines what your platform will actually be able to produce. This is, Mel Conway wrote a paper in 1967 called How Committees Invent. And I think one real problem when people want to move towards continuous delivery of microservices is that they think they have to reorganize into like 2 pizza teams, because Amazon does it. But we talked about cargo culting. You don't necessarily have to do that, because Conway's law does not say your software will copy the structure of your organization. There's a very important word in there that people leave out a lot when they're talking about this. It will copy, your software will copy the communication patterns of your organization. So if you have those 2 pizza teams but they don't talk to each other, your microservices are going to be terrible. You need to have good, clean APIs between your teams just as much as you have between the disparate parts of your infrastructure. You have to, basically, if you're, as developers, going to read the Heroku propaganda and drink the 12-factor Kool-Aid, and you want to do that, which is awesome. I think 12-factor is great. I also think it's not completely mandatory, and maybe you could do like 7 or 8 of the factors. I mean, that's better than none. But if you're trying to do 12-factor apps, just take logging, for example. If it says in 12-factor that you should definitely have your logs all right, an event stream to standard out. Well, that's super, but where's that going to go? Your platform helps mediate that contract between your operations and development functions, whether or not those reside in the same team, but between those, deliverables as to if you have your logs going somewhere, if you're writing your logs to somewhere, then something is there to receive them. Like every single one of the 12 factors you can look at and say, there's an implied promise in here that there is a handshake that needs to happen in order for this to go anywhere, to be operable in production. And this does not remove responsibility from developers for writing code that is actually operable in production. It's like, yes, your query probably needs an index. Like, start there. Think about that, right? But if you're trying to bring change to your organization, if you're trying to get people to do any or all of the things on your wish list, and yes, I haven't forgotten about security, and security is actually super relevant here. If the easiest thing to do is to write their password on a post-it on their monitor, they will. If the easiest thing to do is to just open all of the ports because they cannot figure out which one to open, they will. If the easiest thing to do is to punch that hole in your AWS security group for your Comcast, cable modem IP at home, and then just add a new one every time but never remove your old one, and that goes into a production database. And I may have totally found that after getting a PCI level 1 compliance audit at a previous job. And I was like, what were those auditors looking at? How did they miss this? But whatever is easy for people to do, like nobody comes to work trying to do a bad job, and nobody comes to work wanting to write something insecurely. Nobody decides that they will completely ignore, for example, all permissions and just mount a file system in so that their container has like complete root access to write things to their host instance. Nobody does that because they want to do a bad job. They may do that if you have not given them any kind of facility for log handling, so they figure they have to write the logs somewhere and the containers are coming and going. And I've totally done that. Like, all right, we'll just write the logs to the local disk of the host instance and then ship them off with an Xlog. And it's like, was that the best way to do it? No. Did Docker have their event stream log handling stuff at the time? No. And so it's like, we did what was expedient. And so if you can make the easy things the right things, if you can make the things that you want people to do the ones that are going to be much, much easier than the alternative, they'll probably do those things because they want to as humans, we're really good at taking the shortest path to get something done. And whether it's, not wanting to backtrack or figuring out the exact fastest way to drive someplace where you'll miss all of the lights, like we're really good at that kind of optimization. And so giving people something that even feels like a shortcut but isn't, specifically in the case of your containers, microservices, platforms, etc., allowing the applications to talk to each other via APIs, publish the APIs, version them so that people don't feel trapped and feel like they can actually iterate on their applications and still maybe support things that are legacy. Because, I mean, I got news for you, right? Like, legacy basically means the thing that makes us money. Like, okay, why are mainframes still around in a whole bunch of giant retail and banks? Because that's where the money is. And nobody is going to disrupt that into a container anytime soon, and that's actually okay. Like, when you're making platform choices, putting things that you don't actually need to deploy very frequently and that you're not iterating on, trying to forklift those into whatever your cloud du jour is, or trying to forklift those into your new frameworks or new platform is probably a waste of time. Now, this does not mean I'm advocating for bimodal IT. I'm not saying you should have haves and have-nots, and some people get to play with all the shiny new tools, and other people just get to be sad all the time. I'm just saying that when making tool choices, there is a more nuanced view than can this particular PHP hammer solve all our problems. It's like, reality, there is no tool that will solve all your problems. So making iterative choices towards tools that will improve things is a lot more useful than trying to do one giant procurement for the magic tool and then try to move everything into that through like a giant like ERP migration process, and then that doesn't go well, and then, I don't know, N years later, some CIO gets fired, and then the cycle repeats. Like, we've all worked places where that stuff has gone on, and that's actually not useful. The useful thing to do is to empower people, give them the tools they need and the access they need to do their job. Even if that does mean, yes, disrupting, we have to throw the keyword in there somewhere, even if that means disrupting people's very specific fiefdoms and power structures of, I'm the department that can spin up VMs and nobody else should blah, blah, blah. And it's like, yeah, you're probably gonna have to change, and maybe you're gonna have to learn to do something completely different. Maybe that's okay. Like, I think that when we're thinking about making massive changes to the way our organizations work, because make no mistake, when you're talking about your build, ship, run, pipeline, like, for a lot of organizations, that's basically that's the underlying infrastructure of how you're going to get your job done every day. And it's no small matter to make big changes to it, but it is a small and pretty easy matter to make incremental small changes. So every one of the things that we've talked about here today, like, you can probably do N of these things, or N is probably not all of them immediately, but you can do some of these things. Even if it's just making sure that the people on that team who always tell you no, know who you are as a human, and you talk to them in Slack, or you talk to them on GitHub, or you talk to them over coffee and bagels. Like, that is actually gonna get you a lot farther than, for example, back at Drama Fever, the ops team and the front-end development team had some conflict, shocker, and we, after some static, single-page app stuff that they would drop in S3 right from their laptops and never check into source control, that would be subtly broken and no sadness, and so we were like, okay, S3 bucket access revoked, you have to put everything through the build system. And they were, full of sadness and thought that we were terrible, and spending a bunch of time with them, both on Hangouts and even, I went to New York and spent time with them in our New York office in person, spending time with them and then figuring out which pieces of our build system were painful for them, containerizing some of the stuff that they were doing, which I gotta tell you, like, NPM and Bower do not wanna be containerized. Like, Bower makes a lot of assumptions about your CWD, and you have to put a lot of flags in there to turn off all of the, expects to be interactive sort of thing. But, like, I had to reach out a little, they had to reach out a little, and we got to a place of a lot more harmony. And I feel like that's how we can actually improve this sort of thing. So, again, it's like empowering people and giving them the tools that they need in order to have them actually do the things that you want. It's like a much more useful, work hack, life hack, whatever, than trying to impose your will on them. Like, speaking as, a recovering BOFH sysadmin, I've tried both, and the cooperation method works a lot better. This is basically the cloud native advantage, right? So these organizations that seem to be operating at a pace and innovating in a way that looks impossible to a lot of us mere mortals, they're doing this. They're picking something simple, iterating on it, empowering people, letting them move, at speed, at scale. Like, they aren't unicorns. It's not magic. I know plenty of people who work at, Google and Netflix and Facebook and Twitter. Someone who works at Netflix was just talking to me, just yesterday, the day before, just emailing me about some Docker registry stuff. or I think he direct messaged me on Twitter, and then I ended up introducing him via email to some people who are doing some like extending the open source Docker registry stuff. It's a entire community of people cooperating, and you plugging yourself into it is a really good way to go. So that's pretty much it. That's my talk. That's my pitch. It's like, go out, be excellent to one another, and the becoming cloud native thing will sort itself out. So yeah, thank you.